we'll look at some oxidations of alkynes by permanganate. We have an internal alkyne. It's going to be oxidized by permanganate, and in similar vein to the oxidations by permanganate of alkenes, it will form alcohol groups, diols. But in this case, it's going to lose two of these, and what will be remaining is a diketone. And this is for permanganate that is cold, not heated, and neutral. And what we'll see is that at different temperatures, like in alkenes, if heat is added, then what we can get is cleavage. So we'll look at both. So this was for an internal alkyne. For a terminal alkyne, the same thing happens. We get this diketone, but what will happen here, we have this oxygen, it will undergo further oxidation by permanganate, and it will leave an alcohol. So this is now an acid instead. So here's the difference. Carbon group here, alcohol group over here. So this is a carboxylic acid. Now, if we want cleavage, what we can do is add heat and make it more basic. Under these conditions, an internal alkyne, under basic conditions, and with heat added, it will have a diketone, but then it will undergo further oxidation and cleavage. From here we can add protons if we use a dilute acid to these oxygens, and it will leave two carboxylic acids is the result. Actually, I probably should have drawn this over here, but oh well. It's the same thing. It's going to cleave where the alkyne was, and it will have the double bonded oxygen and the alcohol group. And we can't use too concentrated acid, otherwise it'll begin to interfere with this oxygen and other things. So we use a very dilute acid. For terminal alkynes, this one's a bit interesting. So we've got the same thing happening. It cleaves as in the previous example, but here there's this oxygen. So let's see what happens to this. Nothing special will happen to this, so we'll simply add a hydrogen to it like in the previous example, but this has something different happen. It will undergo further oxidation, similar to the terminal alkyne in the dilute solution. So what will happen is we'll get carbonate. That's what this is. It's going to oxidize this hydrogen, will be replaced with this oxygen. Protons will be added to it, and this will be at equilibrium with carbon dioxide and water. And if this is done in an open atmosphere, what happens is that this just floats away as a gas. So all of this leaves unless it's in some kind of closed container where it can go back to this. But if it's in an open atmosphere, the only thing we will see in the solution is this, because this will be going away as a gas.